2.5, right?
All right, what's the ugly part, Walker?
1 minus x squared.
So du is equal to negative 2x dx.
But
So I'm going to rewrite this so it's ready to go.
But it's 1/3, isn't it?
5x dx. So yes, I'm going to need to multiply it by, now if...
Wait, it's 1 minus x squared is the 1/3.
This is the 1/3, sorry. Okay, so you need to make a 5 into a negative 2x dx. So what do we multiply by?
I don't know.
How about negative 2 over 5?
Why do you simplify things like that? So
That's negative 5 over 2. To make it 1.
So we're actually getting bigger afterwards. Okay.
Okay, folks, eyes up here for a moment. Okay, I had a 5x and I wanted to make it negative 2, right? Simplest way to go about that, again, some of you have got quicker math, you've got math set, great, use it, okay? Simplest way to do that is to divide by 5 and multiply by negative 2, right? So I simply multiply by negative 2/5, and then I flip and multiply out in front, right? So whereas we were using 4 before x, then we put 1/4 out in front, I'm just going to flip and multiply to make it a 1s, right? Because 5 times 2 and 2 times 5 is always going to give me 1. So see the steps? The steps are, if I look at this, I got a 5x here, I want to get rid of that, so I'm going to write it as negative 2/5. That cancels out that, and then flip and multiply in front, and then I'm good to go. Does that make sense? Everybody good? All right.
Books are going to start coming out.
Stop the pounding.
Warriors don't cry. Okay, Peter. It's an interesting book. Whoops. What's happening? Oh, it's a trap.
Mr. Resney,
Yes, sir.
are improper fractions considered okay for writing your answer?
Yes. I say that totally troubled by that, but yes. Don't tell the college professor I said that. So, first things first, Mr. Nix, what is different about this one?
It has your bounds.
That's my bounds. We call it definite interval. So I'm looking at this and I go, all right, so far as I know, all that means I plug in the numbers at the end, right? With a minus sign in between. So I'm going to go ahead and approach it the same way. Is that okay with you? So let's start out by approaching it the same way. Give that to me.
All right. Put a U.
Put a U in there. U is equal to?
X squared plus 1.
X squared plus 1. I love it.
Then you derive that.
du dx.
And you get 2x.
2x.
And then you bring that dx across.
Bring the dx across.
Now, put it in terms of U.
Put it in terms of U.
So you
Now, you're doing that all in one step? Can I have one more step in between?
First of all, you have to set the U equal to whatever the U is.
Right. And I don't have that naturally matched up, right?
No, so you have to put a 1/2.
So let me switch this out temporarily. X dx, and then x squared plus 1 to the third. Okay, so what do I do?
You put a 1/2 out in front.
1/2 out in front, which caused what to happen?
Causes that should equal.
I get a 2 there, right?
Yeah.
Which matches up nicely with this. With me so far?
Precisely.
Now, the next step, I'm going to switch everything to you. Everything to you. Ready?
Yeah. So
All right.
1/2.
1/2.
And we're thinking u cubed
U cubed, love it.
to u with u.
Du, right? With respect to you.
Yeah. And then then you have 0 and 1. So that's like
Yeah, but those are in terms of what?
x.
X. That's an X value, isn't it?
Yeah.
I said we're switching everything to U.
Is that
How am I going to make that a U value? When X is 0, what is U?
0.
Why is it 1, sir?
Because we set it equal to u.
If I put a 0 in for X, what does U become? 1.
Okay.
If I put a 1 in there, U becomes 2.
Awesome.
So far, so good?
Yeah.
Now change everything to U, right?
Absolutely.
Okay. So I'm going to go ahead. Give me the next step.
1/2.
1/2.
Oh wait, actually,
No,
we
not
have
the same.
1/3. Wait, 1/4.
It's safer to raise the power first, divide by the power I get, right?
Then that's it. Well, plus e
Plus C from
from 2. Well, 1 to 2.
1 to 2. That's the way we'd say that. Okay, so I've got that set up.
C.
Now, what's interesting about this moment is, do I have to go back to X at all?
No.
Wait, shouldn't it be 1/3 instead of 1/2? Because it's raising the power. Or,
No, this was to make the
Sorry.
2X.
I'm being stupid.
No. Good question. Are you with us up? Okay, Mr. Nix.
C.
Do I have to go back to X at all?
No.
Why not?
Because you already have it in U, so when you find it in U.
These are already in U. All they want's a number, right? I never have to go back to X at all. Why go to X? Why go back there? Because then I have to switch these back again. Now, philosophically, listen to me very carefully because I'm going to make this point. It's a weird point. It's a point that calculus teachers talk about late at night when they have nothing better to talk about. And that's this. You are always safe as long as you integrate responsibly using U. In other words, I just put a 2 and a 1 in there, I'm always safe. There are always 3 or 4 students in the classroom that want to put the X back in and then put the X values back on and then do it that way. If you do that, you run into no trouble at all this year. But there's a problem with that. I integrated with respect to U, did I not?
Yeah.
Totally ignoring what was happening with X. If X is a weird function that somehow becomes undefined in the middle or something weird like that happens, can I catch that when I'm integrating with U? Then if I just plug in my X values, am I really going to get the right answer? No, I'll miss the fact there's something weird going on. Does that make sense? So theoretically, you should never go back to X. But if you do this year, you'll never get a single problem marked wrong. That's weird. Okay? So, for most of you, the simple advice is just plug in the 2, plug in the 1, and call it a day. Fair enough? Make sense, Karis? All right, we'll put the 2 in there. So I get 1/8, 2 to the 4th, minus 1/8, 1 to the 4th. See a smirk or two?
Wait.
You with me?
Why not? Why are you working much
Oh.
You're good? Okay, so 2 to the 4th is 2 times 2 times 2 times 2, which gives me 2 minus 2 times 2 times, no, 1, gives me 1/8. So what do I get? 15/8. Or 1 and 7/8. By the way, that's the preferred answer by most college professors. This is totally acceptable by anybody who's going to grade your stuff in the next year. And there is actually a lot of college professors which will be for with that too. But you've been warned. All right, you good? All right, 73 through 25. Go.
25. Seriously, the numbering system is actually the worst.
It's worse than that. I think there was something on the back of this when I first copied it. I don't know what happened to that. You guys lost about 12 problems. It's going to be terrible for you.
No, the one was like 31 to 32, and it was like 10 problems.
I know.
So 27 times 4.
12 minus 8 root 2.
Oh, that's weird.
Oh, I could just write that as
Okay.
12 minus 8 108 minus 8 root 2 minus.
Wait,
Seriously? Extend that. Yeah, that's my answer. Look at 8 minus 8 root 2 minus.
Yeah, do I? Hey, that's what I have. It's not, no. That turns into 4 nines.
It's 100
Oh, yeah.
minus 8.
That's what it is.
Oh, okay.
You does stand for ugly. You should expect
Wow.
Oh, funny.
4 divided by.
3, 1,
Yes, now would be a good time.
Your word's not here.
I know you're late.
She left already?
She left already.
We can give it to her.
I will give them to her.
Oh yeah, someone told me they're gonna. Who was it?
Yeah.
Someone told me to do that.
I got 8,706 minus 12. That's not what I got. Let me double check the number on the second one.
Alright, I got 10.74.
Wait, that's not good.
I got 12. But I didn't get his other number. Oh, I didn't. Alright, I'm circling my answer. And please God,
That's my answer.
root U.
I got 10.743.
Just 2.
You got, okay, I got 8,700.
Look at that.
What? That's not right, Peter. I got what he's getting at.
It's 2. Okay, it's 2.
Oh, it is 2.
Square root of 9. Hey, I haven't done that part
Oh. Yeah, I screwed up. I screwed up.
God, I hate this.